Hey, welcome. And I'm Taylor Dawson, developer advocate at Amberdata. Really excited to be sharing with you guys today about building applications with Amberdata's API and using Web3data.js. So here's kind of like what we're going to go through here. So first, intro to Amberdata in case you don't know about us yet, and then we're going to look at our API, what it includes, and then we're going to be looking at Web3data.js, our WebSockets, and then finally we'll have some time at the end to ask questions. We love feedback. So whether it be this webinar or using our tools, website, anything like that, please feel free to shoot us an email. Follow us on Twitter. You can DM us there, or even on our website, we have intercom. So you can send us a message right there. We usually respond pretty quickly to the intercom messages, as well as email. Right. So what exactly is Amberdata? So Amberdata is like your one-stop shop for all your blockchain data needs. We have multi-chain support, market data and blockchain data APIs. Some of our endpoints, blockchain data endpoints actually include market data injected right in with the blockchain data, something that we haven't seen before. We have blockchain analytics, metrics, and security. You can see our dashboards and panels and even use our Explorer for Ethereum. So here's an example of some of our panels that we have. The top left, you'll see statistics related to network metrics. And then you can see different things about transactions. And then at the bottom, you'll see vulnerabilities overview, which kind of gives you a look at smart contracts that are on Ethereum and some of the vulnerabilities that you'll find in them. We run scans on smart contracts as they're published to the Ethereum blockchain. That data is also available via our API as well. We actually have a security endpoint. Okay, so to begin, we grab our API key. It's fast, it's free. We have a nice little onboarding page here, which kind of like walks us through the steps. So we go through and we create our account. And then after that, we can select to get a free developer API key or professional enterprise, depending on your use case. And then after that, we have our API key. We can start going ahead and testing out the API. We can add our SDKs, what we're going to be doing using Web3data.js. And I'll show you in a second our documentation. Actually, you're able to test the methods right there. So here our API, over 100 endpoints and counting. So we have real-time and historical blockchain and market data. The real-time data is available via WebSockets, something that we'll be talking about today. And historical time series blockchain data that's usually very difficult to obtain without storing the entire history, which not everyone can do, but we do that for you. Multi-chain data, so same endpoints, as you'll see, you can get different data, or sorry, same data, but different blockchains using those endpoints. And then JSONRPC support for people who want to use direct calls as if they're talking to Bitcoin CLI or Geth. So this is our documentation here. You can go ahead and explore that. On the left-hand side, you'll see a list of all of our endpoints that we support. It's quite extensive. And then again, each one of these, you have the ability to, which I'll show you in a second, test them out. So then we have our WebSockets, WebSocket events, and then our JSONRPC methods as well at the very bottom here. So for instance, if we're going to get a block, we can put our API key right here. And then once we do that, we can try it out and we'll get live data coming back so we can easily test that. It's pretty neat. Okay, so like, how does this multi-chain support work? So what we've done is we've made it as simple as changing a header. So you can choose between different networks. So whether you're on Ethereum, but you want mainnet or you want Rinkeby. And then lastly, if you want Bitcoin, you can just change your header to the Bitcoin blockchain ID. You can find those blockchain IDs in our documentation as well. And if you're using Web3data.js, it's even simpler. You initialize your. We'll talk more about the entirety of how to use Web3data.js, but basic overview. Once it's initialized, you have your API key in there. You can select your blockchain. This is an interesting case where you're starting out with an instance of Web3 data that's pointing to the Ethereum ring key. So you could use that for your development. And then once you're ready to like go into production, you could use your ETH namespace, as you can see here. Now the .eth namespace is pointing at Ethereum mainnet. And then, for instance, if you would like to get the balance of an address now for Bitcoin, we can just namespace this BTC, and now we're hitting the data coming back from Bitcoin. And so as you can see there, there's 3 different ways we're getting the balance, and they're hitting 3 different networks, which is really cool. Makes it quite handy. And as we see kind of blockchain trending that way towards a multiverse of chains, so to say, it's going to become even more important to be able to have an easy way to like watch value transfer between chains. And that's really what we're aiming to do here. So Web3data.js is an open source JavaScript SDK. It makes it really easy for if you're a dApp developer to start building with Amberdata's API, or it's great for even like researchers, traders as well, wanting to make trading bots. There's like a lot of use cases for that, not just for dApps, but that's primarily the primary use case there. So it's pretty intuitive library. Try to make it as easy as possible to use, and it's simple. There's like what I call smart logic under the hood. So there's instances where you'll have a method, for instance, I think it's get balance, where in one instance you can just get the current balance, but if you specify historical filters as seen in the Amberdata's API, it will actually go and get historical balance. But it's the exact same method. It just depends on the way you're using it, which is pretty cool. And as well with WebSockets, as you'll see, there's a lot of smart logic under the hood, a lot of housekeeping that it does for you. So because of all that, it will really free up your development time to focus on the core logic. In the future, we're looking at building a similar tool in different languages such as Go and Python, but that's yet to come. We're also working on a documentation. Has everything you need to get started and get set up. We're adding more and more methods. And under here, as you can see, it will give you details on the usage of each method. And so we're very soon to having that fully fleshed out. It's really exciting. Okay, so basic initialization, you install Web3data.js, and then from there you can start using it, kind of like what we looked at earlier. You import it, instantiate it with your API key, and then from there you can start calling methods. So the default would be Ethereum mainnet. If you want to specify a different blockchain, you can specify the blockchain ID like you saw earlier in the example, and then also using namespacing. So if we wanted to hit Ethereum mainnet, we would namespace with .eth or .btc if we wanted to do Bitcoin. Okay, so I'm going to show you an example real quick about using, well, first we're going to look at the documentation for our API endpoint, getting the transactions of a block. And then I'll show you what it looks like to do that with Web3data.js. Okay, so here's this endpoint. Basically, you give it a block number, and it will retrieve a list of all the transactions that are in that block. You can also specify that we want to include functions or internal messages that were also contained in that block. We can include token transfers. So the difference being here, functions or internal messages usually are what's carrying the token transfer itself, but it's like the raw form of that data. And then including token transfers will actually include that transaction as a token transfer, and you'll be able to see the token transfer data already parsed out for you, which is just really handy. And then we can also include logs, validation methods. So this would enable us to include data that would be needed to validate that transaction within that block. And then lastly, we have the ability to include the price and then specify currency. So this is kind of what I was talking about earlier about kind of marrying blockchain data and market data together. We can actually include the price attached to each transaction so we can see the value that was transferred at that time with the Ethereum price as well. And I'll show you that what it looks like with Web3data.js. It'll come back in a pricing object, which will be a lot more clear when you see that. So I put together a little run kit here to kind of showcase this. And this is actually a line out of a demo I'm going to show you at the end to get some of the data that I needed. But okay, so basically, again, we have our basic initialization here. And we're using block.getTransactions. And as you can see, Web3 data closely aligns with our API as the namespacing kind of relates to that, as you can see here, block.getTransactions. So first, we specify the block number. That's the first parameter here. And then the second parameter are going to be our filters. So like we saw back on the documentation, we could include a price, and that was a Boolean. And then we could also choose to include token transfers. And so actually what this does is I'm using this method to get the total amount of Ether that was transferred in USD for that specific block. So that's what this line right here is doing. So we're including a price, we're including our token transfers, and then to get the total ETH transfer, I'm doing a reduce across the array, and then I'm adding them up and then parsing it and then getting that total value there. And that's kind of the object that's coming back here. But we can actually, what I'll do is remove this line so we can see what the data looks like coming back. Here we go. Right. Okay. So in this block, we had 46 transactions, and here's the data that we got back from that. So each object in the array is going to be a transaction. So here's a specific transaction. We can see the block number that was at. Obviously, it's going to align to the one that we specified. And then the number of confirmations. It wasn't a contract, so a contract wasn't deployed in this transaction. So it's actually going to have a contract address of null. Then we can see the fee here as well. What I was interested in showing you was this pricing object that comes back because we had specified to include price. So the pricing object is going to tell us, hey, so we want to see this field in the object. We want to see this field as in ETH, or sorry, in USD. And this is the quote price. So when you're looking at historical transactions and you want to include price, the quote price will tell you, is essentially telling you this is the price that it was at that time and that we're using to derive the amount in USD. In this case, it's USD. And right here, so here's the value field, and they will match like that. So this value field is being multiplied by the quote in order to get our total, which is $126 in some sense. And it's also including token transfers. So it's actually possible. I don't necessarily want to search through all these to find it, but it's actually possible to see. Oh, there it is right here. So this is the token transfers object that came back. So this specific transaction contained token transfer. In this case, it only contained one token transfer. So in this transaction, here's the hash. So in this transaction, we had one token transfer, and it transferred, it looks like we transferred DAI and a good amount of it. Now, this amount is in the lowest denomination of that token. So in this case, we'd want to multiply it by 10 to the -18 to move that decimal place over to get to kind of the right amount there. But that's kind of what we're looking at. So this is really cool. So we got our token transfers, we got for each block, and we also got the pricing data, which is pretty powerful. So remember that, because we use that in the example I'm going to show a little bit later. Okay, so now we're going to kind of move into WebSockets. So this is kind of the core of the demo I'm going to show at the end is WebSockets, but that's a little piece of it what we just looked at. So our WebSockets, it does a few things. It's also, I'd say, intuitive. It conforms to like standard WebSocket implementations like .connect, on, off, once, and disconnect, things that you're probably very used to. It abstracts the way JSONRPC, which we'll look at in a second, which is the way our WebSockets work. It's the way that we interface with them, and it's compact and concise. So it really makes getting real-time blockchain data a lot simpler than we've seen before. So here's a few support events. If we look in the documentation, we can see all of them. So we have our blocks, transactions, pending transactions. So that every time that we see a pending transaction into the pool, boom, you get a notification, and then a bunch of market data events as well. So JSONRPC, basically it's a stateless lightweight remote procedure call protocol, and we use this with our WebSockets and obviously with the JSONRPC API. So these are two different places that we're going to be using JSONRPC. And again, a lot of the times Web3data.js is abstracting that away. But for instance, if we're going to do this manually, this is kind of what it would look like. So with our WebSockets, we would send a subscription request. We say, hey, I want to subscribe. This is the method. I want to subscribe to every block, or actually in this case, we're subscribing to a specific block number. This is a block number in the past, so it wouldn't make as much sense. But essentially, let's say there's maybe a fork happening at a block in the future. We could subscribe to a specific block number. And then once that block gets hit, obviously you're going to get a notification. It's going to be kind of handy for that thing. So the first parameter is the event name, and then the second one will be the filters associated with that. Next, we'll receive a response from the server, and it would say, hey, we acknowledge this request. Here's the ID that you sent us. We're going to give you back a server-generated ID. Keep this in mind. Each server-generated ID will correspond to a specific subscription request. So there has to be some kind of like bookkeeping in the background to kind of match responses with that server-generated ID. So now we know we have an active subscription. Now when an event comes in, we're going to see the similar format here. This time we're going to have parameters that have a result and a subscription. So the result is going to contain the raw data, and then here's the subscription, which is again the server generated ID. So when that ID comes back, we'll kind of know like who subscribed to that and what we want to do with that data. And so again, that's something you'd have to like work with under the hood. So without Web3data.js, just like basic WS module from Node, npm, you would set up, this is the WebSocket URL. So you would set up your WebSocket, apply your headers. In this case, we're looking at Bitcoin with the blockchain ID. And then you could subscribe here on open. We want to send a subscription. And then when we get a message back, we want to parse the JSON. In this case, I'm stringifying it. But we want to parse the JSON, and then we want to get the subscription ID or back from that data, and then we'd want to do like a switch case statement to kind of anyways, there's a lot of logic under the hood there to kind of like keep those subscriptions in line. Let's say if you subscribed to let's say blocks, transactions, internal messages, and uncles, right? So you kind of want to be able, you're going to need to be able a way to keep track of them all together. But with Web3data.js, we made it a lot simpler, obviously. So again, similar where you're initializing with your API key and a blockchain ID. Again, in this case, we're doing Bitcoin. And then we're going to initialize the connection, and then we're going to subscribe with our on subscription event here. And then the block data will come in, and we can log that block data. So here's an example. This is looking at Ethereum. Same initialization here. We're going to start up the connection. And then in this case, we'll subscribe to the block event. And because it's on a run kit, I have it disconnect the connection right after we get block data. But we could keep going, obviously. We're doing an on subscription. So we could do a dot off, which would unsubscribe, but stay connected to that WebSocket. And here's an example of the data that comes back in this block. So one thing to note is that the data coming back from a WebSocket is going to be like kind of like the raw blockchain data. Our get block endpoint on our API, or even with Web3data, our get block endpoint will include a lot, actually some additional information that our WebSocket might not. The WebSocket is meant to speedily return that block data as quick as possible. So there's some additional metrics that the get block might have. For instance, we don't have the number of token transfers, which is why I used the get block transactions method to add up all the number of token transfers that we had and get that number manually. similar to the getting the total value that was transferred in the block, which I think is really interesting. Okay, so what we did is this is something that we worked on a while ago, but it's kind of an example of what it would look like to use like a really simple example of using our WebSocket endpoint, and we wanted to kind of make it fun. I'm running it locally. It's something I was tweaking a little bit, but I'm going to push the changes soon. We have a repo that you can look at as well, and you can feel free to like clone that or fork it and then play around with it. It's really meant to be like a really basic example of what it would look like to subscribe to WebSockets and then actually combine some of that data with our market data as well. And so basically a block comes in and it tells you the block number. And then for every transaction in that block, we create a little box that says transaction and then an internal message. And then what we did when I showed you earlier with Web3 data with that run kit was I was getting the total amount. I wanted to know the total amount of ether transferred in that block. Yeah, so anyway, so what I did is I got all the transactions, including the price data, iterate through them, and then accumulate that and get the total amount. And then that's what I was doing here to kind of show you we can kind of get a sense of value that's being transferred for a block, which is pretty interesting. Something else would be interesting to look at would be to include token transfers and then adding up the value of in USD of that token, and then the amount that was transferred, and then can kind of see, gives you like a much better idea of how much value is like kind of moving through the blockchain, which is pretty cool. Yeah, and so this repo, you can see distinctly what it would look like using Web3data.js, putting that all together. So this one particular is subscribing to a block, transactions, internal messages, and uncles, I believe. So when any of those come in, it will automatically start triggering the UI to populate. And then the fireworks are just kind of a fun addition. And obviously the color corresponds to the color in the block. So if it's a internal message, as you can see there, a bunch of internal messages came in. So it's going to like fire off a bunch of blue fireworks. And then if it's a transaction, it fires off a red firework. It isn't it's proportional to the number of transactions and internal messages, but the number isn't spot on. We did it before where it fired a rocket off for every single transaction, every single internal message, and it just like bogged down the UI. And then for example, if you click on view, we can actually go see more details about that block, and then it kind of takes us to our Explorer, which gives us a bunch more details about this block and kind of things that we saw during that block. Yeah, so that's that. Again, this is up on, it will be, I had added something, but this will be up on our Git repo. And you can check out the demo that's actually live on GitHub pages. All right, so that's it. Really excited, and thanks for listening. If you have any questions, you can either ask them now and I'll try to answer, or if you have any questions afterwards, just feel free to reach out to us. So I'll give a few minutes for people to raise hands and we'll go from there. All right. If there are no questions, then I'll go ahead and close off here. Again, like really excited that you're here to listen. Really, and thank you for that. Thanks for taking time out of your day. Slides are going to be published, and you can go on our website. Feel free to check out our documentation and explore more about our API. Follow us on Medium and Twitter. And again, if you have any feedback or anything else, please feel free to email us, DM us on Twitter, message us on Intercom on our website, and we'd love to hear from you. Sweet. You guys have a great rest of your day.